Okay, so we were cut there. If we use the formula for minimum reflux, this would be your minimum reflux. The 1.17 minimum reflux ratio, that is. So for letter E, if we are to determine the minimum number of stages, the operating lines will all coincide to the 45-degree line. In that case, you have to disregard all the things that you have written here, the operating lines you have written here, and you will simply draw the steps based on the XD and the X sub W. Now, you can see that it's 5 point something, 5.8. So you subtract 1, that would be 4.8 for the minimum number of stages. Now, you could see also in here that the X prime and the Y prime represents the coordinates of your uh, intersection point of the feed line on the equilibrium curve. So it's in here. So it's anyway in here on the diagram already. So as for the optimum reflux ratio, that would be 50% more than the minimum. So that would be 1.17 times 1.5, and that should be 1.755. Now, if you would be asked, just in case, so I did not include it in here because I am apprehensive that we won't have time for that. Just in case you would be asked for the optimum number of trays, you will have to redo your plotting of the enriching section operating line only. Your feed line is the same, but your enriching section operating line now will be plotted based on this reflux ratio, which is 1.755. It will have a new y-intercept, and as such, your orientation for your enriching section operating line would be different than the original. It will have a new point of intersection with the feed line, so that new point of intersection should be connected to the X sub W in here uh, to be able to draw the stripping section operating line. And just like what you did with the previous determination of the theoretical number of stages, you just simply draw the steps from XD again to X sub W or beyond X sub W. Subtract 1 from that. That would be your theoretical optimum number of stages because it's now based on the optimum reflux ratio. Anyway, the procedure is just the procedure. So as long as you know how to find this one, the rest of the procedure could be, the rest of the procedures here discussed could be repeated. So this is how we determine the required information using the graphical approach. So it's actually a mix of graphical and analytical because we also solve in here. It's not purely graphical. In the second part of the slide for distillation, we will solve it like 95 to 96%, and the rest are read from a given diagram graph from your Paris handbook. Okay, so this ends the first part of the slides on distillation. So do you have any questions so far to what was discussed?
Hello, Miss. Good
Yes,
afternoon. Si
yes,
Joshua,
okay.
Miss.
Ah,
Miss, mangangkot lang ko, Miss. If, ano na siya, Miss, ang meaning? Sa reflux ratio nga 4:1, Miss. May
reflux
meaning siya.
ratio, meaning if you look at the formula, I'd like to go back to the slide so you would know the meaning. Okay, do you see the slide? Do you see this slide in the
Hindi,
enriching
Miss.
section? Hindi. Okay, I will share again. Where is it? Here. Do you see it now?
Yes, Miss. Ara na, Miss.
Okay. Now, in the original formula, you could see that the R over R plus 1, which is actually the slope of your, shall I say, in this case, the enriching section operating line replaces the ln over V sub n plus 1. But in terms of what you're asking, kay duha ka bilog ang aton reflux ratio. If it's just based on the formula, your reflux ratio is this one, the ratio of ln to V sub n plus 1. But it's just the internal reflux ratio. What we are using when we solve problems is the external reflux ratio. The one that is provided by the problem is the external reflux ratio, although it's not specified that it is external reflux ratio. It's automatically to be assumed that it's external reflux ratio. So the answer to your question, Joss, is this. What does the external reflux ratio represent? It represents it's the ratio of Ln. What is Ln? Based on our illustration in the column, Ln is the total liquid that has flown down into that has flowed or that has deposited at the column and that is introduced into your reboiler. You could see it in the sample problem. I will go back to that. And D is the distillate. So that is your external reflux ratio. And that's the ratio that is being used in the problem. I like to go back to the problem that we just discussed. Where is that? Is this it? Okay, in terms of the problem we have discussed, this is the illustration of the column. So for you to understand better. So your reflux ratio is the ratio of the Ln to D. The reflux ratio that you were asking Josh is this. The ratio of Ln to D. The total amount of liquid that was introduced into the reboiler divided by the final distillate. That's your external reflux ratio. So based on the operating line, though, it should be Ln over V sub n plus 1, this one. But most of the problem uses, not most, all of the problem uses the external reflux ratio, not the internal reflux ratio. So the ratio that is provided for by the problem. So
Okay,
this one.
miss. Thank you,
Okay,
miss.
sige. Who
Miss.
else have a question?
Miss.
Yes.
Smart siya, miss. Bali, miss, kung may boiler, gali, miss.
Re-
Automatically, ang gamiton mo is external stock ratio kay, ano,
Marshall, tanan nga distilling column except the one with the steam has a reboiler. All steels have a reboiler except the steel that uses steam to lower down the boiling temperature of the higher boiling components. So as such, there's no need for you to be confused on what will you use, whether it's internal reflux ratio or external reflux ratio. It's automatic that at all times you will use the external reflux ratio. There's no need for you to know whether my column has an auxiliary equipment, which is the reboiler or not, because most of the time the problem that you're dealing with, 99% of the time the problem you're dealing with has a steel which has a reboiler. In that case, you really have an Ln for that because you have a liquid that needs to be introduced to your reboiler to partly vaporize part of that liquid. Okay, so Marcel, all the time you are to use the external reflux ratio because if it's graphical approach that is being used, it's always external reflux ratio that we are supplying in the problem.
noted, miss. Thank you.
Okay. Some more
Doc,
questions?
Doc
Yes.
Ali, lasa lang gyud, Doc.
Wala ka sa.
Doc, ano gani, Doc, ang purpose, Doc, nga may reflux, Doc, kag may
Okay.
ginabalik ka sa from reboiler, Doc.
Ang purpose kids ng reflux, actually, if you have read your McCabe already on the chapter on distillation, the purpose, and even John Kuplis, I'm not sure which of the two where I've read that, the primary purpose of reflux is, aside from having a large volume of liquid that is flowing down your column together with the feed, because that's the one that's going to partly produce the vapor that is flowing upwards, the primary purpose of the reflux is to improve the purity of the distillate, to enhance the percentage of the recoverable lightest component in the distillate. So that's the purpose of your reflux liquid. The purpose of your LO is that to enhance the purity of the distillate. Did I answer your question?
Okay, Doc, thank you,
Okay,
Doc.
okay. Some more
And,
questions? Yes, yes,
Doc,
Josh.
pwede mo na siya, Doc, ma-upload, Doc, ang solution, Doc, or,
Na-upload ko na ni.
Okay. Sige, Doc.
Oo, ari na ni
Thank
siya.
you,
I think
Doc.
kung nalipat lang ko, kung na-upload ko, kung wala, then remind me kay. Ari na ni siya sa Canvas, I think, sa synchronous na discussion nga,
Doc.
nga part.
Thank you, Doc. Thank you.
Okay. Some more questions? We still have 9 minutes. Your quiz will be covering the first part of or it will cover the distillation, first part, your quiz that is. The second part will be a little longer than this one, but it's not yet there even in Canvas. So we will you just have, by the way, so on your in our asynchronous schedule on Wednesday, I will give the time for you to study because your quiz will be on Thursday. It's good for an hour and a half. And after that, we will discuss the beginning or the introductory part of the second set of slides for distillation, which will now be focusing more on the analytical way of finding these things that we have determined here. It will be not so difficult anymore because you know how to determine the minimum reflux, the minimum number of stages, and all those things. So you need those anyway. You need these things that I have discussed to you so that it would be easier for you to use the graphs and the diagrams that are made available in Paris this time. Actually, there's an equivalent also in Jan Puplis, but it's better that you already practice finding these things. It's equivalent rather in your handbook. Any question? It's clear to everybody. So just message me if this was not yet uploaded in Canvas. I think the only things that I have not placed in Canvas for all my classes are the recordings because I was not able to have it all uploaded in YouTube. We cannot upload the original videos because that would be heavy for Canvas. It will use up the space there, data allocation. So we need to have a link only to be shared. Yes, somebody's trying to ask a question. Is there's somebody who's trying to ask a question? If you have a question, okay. So no more questions. Sige. So I think everybody has a clear understanding of the lesson for today. Again, I will just remind everybody that as to the objective of each of the topics, please click on the learning targets in Canvas because I don't want to discuss those objectives already at the start of the lesson because anyhow, you can read those in Canvas. Those will be your guide in preparing for your quiz and for your exam, meaning those are the minimum learnings that you ought to have acquired for that particular topic where it is placed on in terms of the set of objectives. Okay, so no more question. So let's call it a day, class. As I will see all of you again on this subject on Thursday during your quiz. So that would be 1:30 to 3. And we will have the next discussion after the quiz. Okay, bye for now and thank you.